Okay, perfect. I think we can get started. Thanks everyone for taking out time to join another session of Build in the Cloud. Today we have again a very cool and innovative topic, AI-led future of Web3 gaming. And this time it's actually one of our customers, Ethlas team, who will actually be coming and sharing. Ethlas is a Singapore-based startup. They see themselves as a gaming blockchain software engineering company, and we see them as one of the most innovative companies and startups out there who are not only just bringing in Web3 into the gaming space, but also now GenAI. Today, they're going to talk about how they're leveraging GenAI for in-game assets generation. If we move on to the next slide before we actually get in, just a few mechanics of how we'll run this session. So as you will see, this is firstly a recorded session. On the bottom right, for folks who might be new to Google Meets, you'll see three icons, which is a triangle, square, and circle. If you click that, you have the option to ask Q&A. At any point of time, just feel free to post your Q&A over there. Or in the chat, I'll just post an example question so it's very easily visible. And towards the end, we'll have time basically to take up more Q&A. If you go on to the next slide, quick introduction of the speakers. So today we have Sai. He's one of our Web3 customer engineers based in Singapore. We have Elston. He's the co-founder of Ethlas. And we also have Neaton, who's one of the data scientists for Ethlas. So these three of them would be taking us through the session today. Quick overview on the agenda on the next page. Basically, we'll open up with a short overview of the company. We'll have a very cool product demo. I'm super excited. I've seen this demo a few times and it completely blows away mind when people see it. And then we'll actually go onto the stack to see how they've actually built it. Sai will also talk about our Vertex AI platform, which is basically what is powering all of this. And then we'll have a few minutes towards the end for live Q&A as well. So with that, I'll pass on to Elston, Neaton, and Sai to take this over.
All right. Thanks for that, Pranav. Just want to make sure everyone can hear as well. Okay, nice. Thanks everyone for taking time during a lunch break, after lunch. Hopefully we do you justice so that your time spent during lunchtime and after lunch is well spent. We really want to go a little bit more on an operational level, especially since this relationship with GCP and the Vertex team has been over the last deepened really a lot more over the last few weeks, both on a PR marketing perspective, but even like on an operational level. I think there's been a number of times where both Neaton and Sai have been like sitting side by side, co-building together. So I think we're actually really fortunate and honored to have the opportunity to work with you guys. So let me jump straight into it, but I'd like to maybe give some context and background so that that sets the setting when we show our demo later in the presentation. So real quick, so this is kind of like how we envision the future of AI-enabled UGC, especially in the context of gaming. And this is the setting, right? Us as a young startup, we can never be able to hire, 500 people like what Epic has or what Riot has. So one of the ways that we want to be able to leverage the playing field and also with emerging tech is how can we introduce AI so that one, it solves resource constraint bottlenecks on our side, be it like the pace that we generate art assets. But more importantly, and what we're actually even more interested in, how do we kind of enable this experience to the user so that they can operate to change their experience in the game. So as we go on, I'll probably share a little bit more about the setting of Ethlas. I'll share a bit about background of the company and more specifically our marquee game, Battle Showdown, which we're going to be using this AI-generated portal to put it together and bring that to life. So we're Ethlas. We like to see ourselves as being able to engineer the future of games. A bit of a background. So I think we kind of started early last year. So we raised just a small round that was led by Sequoia, Dragonfly, Makers Fund. So very fortunate to have a Web2 VC, a Web3 VC, and a gaming fund. And of course, a couple of other ecosystem partners that joined in the round as well. A little bit about myself. I came from a product management background. So spent some time at Grab, Airbnb, a couple of e-commerces in China. So that's why I think a little bit more apt for me to take this presentation because it's a little bit more product ops facing. And of course, joined by a really solid team with different backgrounds from both security, from blockchain, from gaming, and from end-sided marketplaces. Ethlas as a whole we have two key verticals. We started in the gaming vertical, but across the way, we kind of gave birth to an internal use case, which is a security vertical. And that is a separate focus. What I want to focus a lot more on today is Battle Showdown, which is our marquee mobile game. And the basis of it really is how can we bring about interoperable IPs. Some of the most popular games, let's say we take Brawlhalla, Smash Brothers, Mario Kart, a lot of the IPs are dictated by the main studios, and rightly so, right? They want quality control. A lot of these IPs have maybe image rights, merchandising rights. So it is a lot more difficult to quote unquote make it UGC. But I think that's exactly where we find the sweet spot that we can operate in and hopefully win as a young startup. And that's why with AI generation as a means from UGC, it fits really well with the positioning that we have. So let me give you some context on Battle Showdown. It's a mobile arena, battle arena mobile game, and it looks a little bit like that. So it's a platform shooter game. It is both on Android and iOS, but we prefer the Android marketplace, of course, a lot more. It's an aggregation of 40 different plus character IPs. And what's different is that these aren't IPs that we control. We have from day one been a platform where we onboarded different Web2 and Web3 IPs so that we become the platform to bring about a different, more engaging experience for them. So for example, we have maybe 20, 30 plus NFT projects. These could range from the really tier ones like Doodles all the way to the tier twos. And we're open to it because we are not going to be deciding, which IPs can come in as long as it brings about a better user experience and it's something that the community likes. We want to open it up. So it has been very, very encouraging because a lot of their main products are mainly as an IP company, right? Either through merge or through the sale of different digital assets. And then being able to see their characters and IP comes to life, be it as a character, be it as a game mode, was really kind of like the sweet spot that we have nailed, where they really wanted to find a very easy way to onboard with us. So they can see the gameplay. We have different game modes, be it heads up, 2v2, 4v4, 8v8. We have many different like mini games as well. And kind of like both the competitive multiplayer aspect, but can be more like simple casual jump quest type of gameplay. And if you take some of the most successful games, let's say if you look at like Valorant or CSGO, what we think we can win on is that it isn't judged solely by how fast you can shut out new content, but because it's a multiplayer, every new game with the different amalgamation of different players, it brings about a different user experience, a different gameplay experience. And that's kind of like, picking our battles, right? If we really want to win the incumbents, which are the different aspects that we can actually win them on. Some background. So we started as a Web3 multiplayer game. I think along the way, we've also realized the TAM for Web3 alone is really small. So that's where we also started tapping on a lot more of traditional acquisition channels and traditional communities. So something interesting was maybe 2 months ago, we ran a week-long tournament across the globe. And some of our top players, I think third player, after the whole tournament, we got on a call with him to get some user interviews. And he told us that he played our game for 21 hours for 7 days straight. And right after the tournament, he said, I just can't wait to like rest and like come back again next week. So I think it was quite heartening to see, really the platform and this multiplayer game that we've created, see gamers get so invested in it. And what's interesting is that some of these IPs are not things that they can immediately resonate with, right? It's not like Mickey Mouse, it's not Ultraman, but because of the gameplay, because of the amalgamation of different IPs, it actually hits a brand new user demographic. So I think that was something happening that we felt we can double down on. So it is a very B2B2C approach because we don't own IPs. We want to continue to be the platform. So a lot of what our BD and partnership team does is kind of like a lot of outreach, both in terms of Web2 brands and Web3 brands. And we've found that this could be a really good way for even Web2 brands to kind of dip their feet into the Web3 market. So we have had maybe Indonesian marketplaces coming in and they would customize their characters, right? In Indonesia, one of the top local food is Indomie. So what their character does is it shoots Indomie. So it really localized to the different cultures. And we can see from the different servers is that people from across the globe, Indonesia crowd, UK crowd, US crowd, kind of like interact against with each other and choosing a different IP that represents them. That is what really doubled down to say, hey, is there more that we can do for UGC, right? Right now, it's kind of like a B2B2C UGC. It is still the communities deciding which IPs they want, but how do we bring that to the end user where they can then bring in their own IPs? And about leveling the playing field, most of the current Web2 games that we see, as much as they say it's UGC, it is still quite skewed towards the skilled users. For example, some of the other apps like Monster Hunter, when they do a weapon design contest, it is mostly skewed towards the actual designers who already know how to use Illustrator, who already know how to use like Photoshop. But it's not something for the mass market. Or if you look at other platform puzzle games, like Sackboy or Sackgirl, you need to at least have some sort of like a Unity background or some sort of dev background to be able to operate in terms of customizing a map or building a level builder game. It hasn't reached the point where like you can hit mass market, kind of like what TikTok would do to enable everybody to make like really cool transitions. I don't know if you remember the days where most of that had to happen on like a Premiere Pro or maybe Canva, right? So that is kind of like the hypothesis that we went in this partnership with Google. Can we allow anybody with no background draw 3 strokes with GenAI, create a production-ready in-grade weapon that they can resonate to and they can customize and bring it into the game? A couple of months ago, we were also the official Binance gaming partner. This is when they were commemorating their 3rd anniversary. So apart from customizing the characters, we customized the whole map to their theme, to their lore. I think that was quite a milestone because, of course, Binance being one of the largest chains around the world chose us as their marquee gaming partner. So I think that was quite a win for the company. Yeah, we ran a couple of like tournaments, like I mentioned earlier. This is the one that the top player played for 21 hours for 7 days. And we see how a lot of these live ops and tourneys kind of really kickstarts the flywheel. And then right after that, it dips a little bit, but then as they prepare for the next season. So this is a very similar trend as to most multiplayer brawl type of mobile games. And I think, kind of putting a pin to what the end goal is, we really like what Robinhood did for finance, where they didn't say, hey, let me charge 5% cheaper trading fees, let me charge 2% cheaper brokerage fees. What they did was, let's put it at 0%, right? There's nothing lower than 0%, but they found other ways to monetize. But that was just a really strong value prop for the users. And I think something like that really can make or break a brand new market. We see that kind of similar in the gaming market, where most of the negotiation power do still lie in the studios and the publishers, but for the gamers and consumers, slightly lesser negotiating power. So I think especially being a younger startup, that's where we're able to take more risks. And that's why we want to be able to flip it around to say, hey, is there a world where you create a tool and let the gamers design something that's production grade, and you can build this economy where rev share truly flows back to them? Even if we look at, let's say, Roblox or Minecraft, they have marketplaces where people can sell assets or people can sell experiences. But like what I mentioned earlier before, there is still quite a bar to go through that, right? I don't know if we have seen like a Roblox map editor before. It is not something that you can do in like 5 minutes. It probably takes like 1 or 2 days to familiarize. So that is kind of like the opportunity that we have seen what GenAI can do in the gaming space. So maybe I'll talk a little bit more about the actual use case within our game. So we see a world where right now we are focusing on the customization of weapons. So when you go to a match, how the weapons look like, how it interacts, that's what we're starting off with. And because it is a brawler type of game, that's really the essence of the game. That's why we didn't start with like emojis, or we didn't start with skins first, we started with the weapons. But a natural extension is how do we allow more customizability in the characters, in the equipment, the emotes, in the skins, and the cosmetics. And yeah, we really think that in the future, anybody can become a game designer. And it's a real simple 3-step process, right? You scribble your idea, you have AI to help you assist in the generation, You can always redo if you're not happy with it, change the prompts, and ultimately be able to share your gaming experience. And I think a little tongue-in-cheek comment, right? LLM were breakthroughs, but a picture paints 1,000 words. I think we could see many different use cases and applications, be it for text, image, or video. I think video definitely is still a little bit, we have been paying a lot of attention in this space. It is still a little bit early. So what we feel is the best in between in terms of the maturity of the product, also for consumer appetite, like image was the medium that we felt best suited for us, especially in a gaming use case. We have seen some other games where, let's say, they use text LLMs models to maybe automate the dialogues of NPCs or automate the dialogues of players. But specifically for our game, where it's a side-scroll shooter game, the kind of image was the best medium that we really ticked all the boxes. And yeah, let's go straight into something that's a little bit more visual to kind of visualize what I mentioned. This is actually a really good hand-drawn input, but my drawings are much uglier than this. So what we want to do is we will let a user have a very simple template or even a free-form canvas, and you can fill in the different colors, the different shapes. And with what we're doing together with Google, we are able to output production-grade assets. And one click, it brings you directly into the game for you and your community to be able to use your equipment. So nothing does better than showing you a live or recorded demo. So what you're going to see is how we start from a hand-drawn or image output. We allow different prompts. For the users right now, we don't show you all the advanced prompts, for the seeds or how close we follow the template or how close we follow your drawings. But in the future, we do want to open up all the more advanced settings and ultimately, one-click instant integration. So as I play, I'll probably narrate a little bit of what you guys are seeing. So this is just like, what the gameplay looks like we mentioned before. So to really simplify the process, we started out with just giving users, hey, here are 4 templates. In our user research, we realized that if we gave users a blank canvas, they normally don't really know what to start with. So to make it really simple, this is how we started with. But we definitely have the capabilities to give you a free-form canvas, and that's something that we want to inch towards to bring it even further for UGC. So let's say someone chose this, right? We gave them a quick tutorial of what it looks like. You can choose the different colors, you can choose the different brushes and eraser. And even in this screen, there was a lot of things that we experimented with. One thing we realized was that most users have no recollection of reference on what this could be. When we told them that, hey, use AI to create your weapons, like they could not understand what that meant. So that's why a lot of the things that we did here was how do we simplify the decision-making process. We realized all they need was just let them try with a few colors, scribble, and see the first output. I think that was kind of like the eureka moment for us. Yeah, so something like that, a very simple 3-color. And this is kind of like something that we were experimenting as we go down the line with more data collection. We definitely can start finessing how the barrel looks like, how the handle looks like. But I think what is a lot more intricate that maybe from this perspective you can't see is even the shading and the highlights of it. We are able to say, hey, make sure that the top part is slightly brighter, the lower part is slightly darker, how the barrel looks like. And for this particular video, the outputs are a little bit more controlled. When we do internal testing, the outputs do get a bit crazy and wonky, but we realize that's also a little bit part of the beauty of UGC. So let's say I select a weapon, I can bring it directly in game. And what you can see is the character immediately uses my weapon. And imagine a map. For those of you who maybe play multiplayer games, imagine when you go into a map and every character, every player brings their own custom weapon to the game. That we feel brings just a very, very different gameplay experience. And right now where we are is we customize the look and feel of the weapon. We have some presets projectile, but we want to take it further to really customize the whole quote-unquote projectile experience, right? How do we think about like the recoil? How do we think about if someone draws a gun with 3 barrels, How do we know that there should be like three bullets coming out? How do we know the projectile of the bullets, the speed of it, even the in-game stats, right? So all of this have a lot of extension and a lot of creativity where we can start innovating. Yeah, so I think even right now we are preparing some social campaign and also some live campaigns where we allow users directly try the whole feature, generate, and also bring it to the gameplay. It is still very early stage in the sense of in the market. There hasn't been anyone that has at least taken it to somewhat of a production ready environment. So it is also something that's very interesting for us to gauge how users interact with it. But mostly it's also a little bit of data collection to see how do people actually interpret what's a good input, what's a good output, and based on their in-app analytics, we can know, okay, what's the conversion when someone decides to bring a weapon into the game. That's how we proxy, if a certain design fits what they're looking for, because design is very subjective. So I think getting users validation is the best way that we can try fine-tune the model. So yeah, this game is already live, Battle Showdown. We are working towards a end of year or early Q1 launch where we bring in the full AI generation experience. But while December is running, we'll already be doing like a social campaign so that users can already solely try the art generation feature before we marry everything together. Yeah, so really quickly, that's like a quick TLDR of the company context, the product, and the use case. I'm going to be handing the time over to Sai to walk us through a little bit more on the tech implementation and API design.
Hey, thanks a lot, Elston, and fantastic walkthrough. Let me quickly share my screen here. Just give me 1 second. Okay, perfect. You guys see my screen, right? Cool. Awesome. Hey, thanks a lot, everyone, for making time. Just a quick introduction. My name is Sai Balaji. I work as a cloud architect for Google. Some quick background about this project before we get into the details. So when we started working with Ethlas on this use case for game asset generation, one of the first things we put together was a design plan around how this platform is expected to be built out and, to be made sure that it was production ready. And as you see on the screen, we sort of had an outline around the functional and non-functional requirements right from day one. And on the left, you see the top three, must-haves that we thought was important for this platform. Since, we're talking about image generation here, we wanted to make sure that the platform can support the standard open source image generation models. And the cloud platform hosting these models is also expected to have some seamless integrations and ready-made quick, facilities for deployment and testing. And the other most important aspect was around fine-tuning the already existing image generation models like Stable Diffusion. And we wanted to make sure that we chose the best fine-tuning technique. In this case, we went with Dream Booth for fine-tuning the open source models and generating these assets. And thirdly, the most important piece, since this had a direct impact on the end user game experience, was the speed of image generation, right? So that was a non-negotiable at all. So, and since this involves diffusion models and images, which are quite data heavy, we wanted to ensure that the best-in-class GPUs and TPU infrastructure was in place before we even got started, right? Now, on the non-functional side of things, obviously, it involved a lot of operational requirements. We wanted ops to be as minimal as possible. This includes starting from how the data, was fed into the system, how the data science team developed and built their ML code, up until how the models were deployed and exposed to the app itself, right? So a fully managed development environment was crucial. And secondly, since this is a module part of the game, we wanted to ensure that the inference of the fine-tuned models could scale dynamically, right? So imagine, say, if there is, on a weekend, if there is an increase in the number of requests, we wanted to make sure that the platform that was hosting the models is able to scale dynamically, and also had access to the GPU infrastructure for quick generation of these in-game assets. And finally, if you look at the last point on the right, we also wanted to make sure that day two ops was given due importance, meaning we didn't want the game designers on the Ethlas team to sort of, keep tossing new sets of images over to the data science team for continuous fine tuning with a lot of manual effort. So we wanted a fully automated MLOps pipeline where all the game designers need to do was upload the images, and all the fine tuning, model hosting, and deployment happens on the fly, right, without any sort of manual intervention. So this is a quick snapshot of how things got started, and with these requirements in place, the next step was obviously to sort of identify the building blocks of this platform and assemble them and ensure that it worked as a single unit. So if we go to the next slide, we essentially have a snapshot of what are the different Lego blocks that were put in place. I think Nathan from the Atlas team would be the best person to walk us through this. Over to you, Nathan.
Sai, thank you. Thanks everyone for joining. So I'm Nathan, a data scientist at Ethlas. So I think we try to put everything together as quick as possible, with as little fumbles along the way. So I think if we look at it at two different perspectives, one for training and one for inference. So we actually look at training first. So we actually looked at Model Garden for stable diffusion. That's where we picked off the open source model. And then we did the fine tuning with Dream Booth based on specific subjects, classes, and captions of the images. And then moving to GPUs. So we used GPUs for training, which made it faster and more efficient as well. So we looked at, the NVIDIA T4s and the A100s, but of course the T4s are cost optimal. A100s are expensive, but they're actually really quick, much faster, but of course they are constrained by some capacity. And moving on to like the inference perspective, we actually utilize model registry, which also supports versioning, which helps us to do some version control here and there whenever we churn out new models. And of course, endpoints. Endpoints is just the online predictions, which helped us with the endpoint hosting. And the good thing about it is because of the scalability of it, it helps us, to spin up like min nodes, max nodes. You can spin up really quickly. So and it's also a fully managed service with monitoring capability. So it actually gives us a lot of time saving as well. So moving on to the next slide. Maybe I'm training architecture. So if you look at the start, the input parameters, which is actually a Docker artifact location for the training image. So where Sai mentioned, when the designers give us the artwork, we don't want to keep having to rechurn it again. So this training image will actually help to, automate this training job. So moving on to the next part, which is to have the Python code to initiate the training and fine-tuning job, which is the Dream Booth part of it, and with the necessary libraries and dependencies. Okay, so now moving on to artifact registry, the job actually downloads the source code, and then moving on to artifact registry, it builds the file, and then it creates the training container, and then pushes it up to the artifact repository. And then that's where we have the full training architecture settled for us. So after we fix up the training architecture, we actually have the info. Slide the next slide, please. Okay, so how do we expose the trained model to the endpoint, which is to the end user application of the game? So we actually hosted the model on Vertex AI online prediction. So if you look at the Cloud Run, which is the backend API, which we will not go into it now on this part because it's not very relevant. So, but we went with option A first. So going through with option A, we used an NVIDIA T4 for hosting, and we had the min port and max port features for auto scaling. which is what we selected as the 60% CPU or GPU utilization, will actually spin up a new pod. So actually we can put like a min, if it's 1, we expect a low load, we can put 1, and then max we can increase it to like, our max quota. So it actually helps us with this auto scaling. And we did a performance benchmark test. So to ensure that we pick the right initial configuration. So for example, we want to support 10 requests per second, 40 requests per second, or 40 concurrent requests or 80 concurrent requests. And what we observed is that we actually have an average image generation of about 3.5 seconds. Yep. And then if we look at option B, which is actually for future scale, the inference endpoint is actually going to be hosted on pods on the GKE cluster with the NVIDIA T4 GPU nodes. So flexibility and control. The reason why option B will have GKE is that because GKE actually gives us better control and fine tuning. So for example, when we'll be enabling GPU time sharing, and also it helps to reduce the overall time it takes to load a container during like a traffic search. So for example, if you're going to have a tournament campaign, then it will actually help to reduce the whole traffic search, or like, help to reduce the time for each generation. So this is actually kind of like image streaming in a way. Yeah. So actually GKE also helps us to future-proof our whole inference architecture, because GKE's native namespace and RBAC features will actually help us to set up a multi-tenant architecture for other game studios in the future. If let's say we want to have to onboard other game studios with their game designers who wants to use our service, so it actually helps us to provide this service to actually other game studios as well. So it will also support other game designers, other game developers. Yeah. Okay, so maybe later. Okay, so moving on to the collaboration with GCP. So we actually I did a summary of like the two pipelines, so which is internal training or inference pipeline. So what we did is we actually curated the training data set first, the very first step, and then we fine-tuned the stable diffusion model, and then we deployed the model, and then of course Vertex AI endpoint where we test. We did some vision control, we do some vision benchmarking, and also some user experience, opinions, user feedback. Yeah. And then moving on to the production ready pipeline, which is on Vertex AI. So we deployed the whole pipeline with Vertex AI. So when the training images stream in, all the way to the fine-tuning, all the way to the deployment of hitting the inference endpoint to generate the images. So we actually deployed it to a model registry to get the endpoint such that we are able to hit the endpoint on our game. And then we do the API call with fixed parameters. And then the last part would be that because this endpoint allows us for easy integration and quick integration, given the time constraint that we had, and also the whole ambiguity of like UGC and everything. Yeah. So actually this gave us that more leeway to actually create more user-friendly assets, HD assets. Yeah. So
Cool. Hey, thanks Nathan for that quick walkthrough. So I would like to just jump in here and touch upon a few aspects of how we productionize this whole setup, right? Now that the training and inference systems were in place, we wanted to sort of ensure that to be production ready, there is one very minimal manual intervention. Like I said, every time the game designer wanted to retrain or fine-tune the model, say today we have the stable diffusion model fine-tuned on a particular set of images pertaining to weapons. Say tomorrow we wanted to sort of do skins, or say the week later, say the designers want to sort of fine-tune the model for, say, specific avatars. How do we ensure that it's some sort of a self-sustained model, or a process in place where the designers can interact with the system in the backend by uploading pictures and have the whole pipeline automatically get triggered, right? So in order to sort of achieve this sort of automation, we sort of try to put together a few Lego blocks. So if you look at it, the first step, this is just a designer on the top having access to some sort of an internal portal running on Cloud Run, which is Google's serverless runtime environment. So basically, This portal is powered by a backend API sitting, written in Node.js, running on Cloud Run, and the designer should be able to upload pictures on the fly. That's step number one. And if you move on to the second step, essentially, these pictures will be handled by a code called upload handler, which again runs on Cloud Run. And so this gets all the pictures from the designer's upload and sort of starts storing them into a backend cloud storage bucket. And in parallel, if you look at it, the same Cloud Run Node.js code will also sort of insert new entries into a no-store database, mainly to track the status of the jobs, right? So basically say, hey, designer A has uploaded a set of images. Here is a new job ID, and I'm starting to, track the status of the job, right? So, and this is essentially done by Firestore for you, where you can create a new key value store collection and track individual upload statuses. Now, once all the images are uploaded, if you look at it, the upload handler now asynchronously sort of publishes a message on a PubSub channel saying, hey, this is the job which was triggered by a particular designer, and the files are stored in this particular cloud storage bucket, and here is the job ID. So the message will essentially encapsulate all these details, and it will be pushed out to a PubSub channel. And what happens next is that you have a subscriber now actively listening to the same channel. And this is a typical PubSub model, right? Where the subscriber is sort of, checking if there are any new jobs out there. And every time when there is a new message published, this subscriber code will pull that job ID. And what it does is it essentially initiates a Vertex AI pipeline job, right? Now, Vertex AI pipelines is basically a GCP component, a service that sort of helps you to completely automate, monitor, and even govern your ML systems. And it's completely serverless, right? So you don't necessarily have to sit and run commands to train your models, pull data from individual locations, build your container artifacts, and then deploy them, separately. All that can be encoded in one single pipeline file. It's a one-time job. And once that is done, every time when somebody uploads these images to a particular bucket, this pipeline job will automatically get created. And what happens is it will start downloading all the images from the source bucket location. It also downloads the necessary container artifacts for running the jobs. For example, if you're using stable diffusion, it makes sure that the diffusion libraries are in place within the container where the training job is done. And it also makes sure that the necessary GPU specifications for your requirements are in place. For example, you can mention things like, hey, I need a Tesla T4 or a A100, or say even a normal machine, right? Doesn't necessarily have to be GPUs. So all that can be encoded in this pipeline file, and the training job begins to get triggered. Now, once the job gets completed, where say the images are downloaded, the fine tuning has happened. Dreamboot is used for fine tuning here, by the way. The model artifacts then get stored in a cloud storage location, and this can be in any format, right? So we're using safe tensors here, but any compatible model can be stored here. And the best part here is that it's just not about storing these artifacts in a location. You can also do versioning with the help of a service called Model Registry, where it's like a central repository where you store all your custom fine-tuned models. It comes with versioning, which will allow you to do things like A/B testing. And once the model is stored, then the same pipeline will also ensure that the custom model is now deployed against an endpoint, which is like an API infrastructure, which automatically gets provisioned for you, and it exposes it to your app, right? So now you can, if you have a front-end app, you can essentially directly interact with this endpoint and start, running your inference. So this is the overall flow. The best part about this is that all this is done on one single platform called Vertex AI. You don't really have to work with multiple, components and services. And once you deploy your inference models on Vertex AI, it's fully managed, meaning you don't have to worry about building your own API infrastructure for exposing your models. There are ready-made inference container artifacts available for you to sort of, plug in and start exposing these models from, scratch. And tomorrow, if you want to do, say, A/B testing, where, say, if you have a new version of your model, you can also start defining rules like, hey, 90% of my requests need to go to model A, while 10% of requests can go to my new model. I just want to test how it works. If the quality of output is great, then I'll probably gradually phase it out. Right. So such things can be done, and it's all available off the shelf on Vertex AI. Right. Now, this is the overall flow. Of course, we sort of had to, put all these things together while also testing things locally. So what I thought I could do right now is give you a quick, view into how this is done in real time. Right. So let me just quickly stop sharing my window. I'll start my, I think I'll start sharing my entire screen here. Just give me a second. Right. So you guys see my screen, right? Cool. Awesome. So this is just, a sample portal. This is no way what we or Ethlas has in production. This is something that I built out internally, just to show you how the whole MLOps pipeline works, right, in an automated way. So think of it like a portal that your game designers can use, a very primitive portal for the sake of demonstration, where you can choose specific images for training. Say you already have a model up and running, and your designer wants to sort of, run a fine-tuned model based on, say, a new class of images or class of weapons or skins or avatars. All they have to do is just go to this portal and upload, right? And now this is being handled by the upload handler, which I touched upon in the last slide. It's essentially running on Cloud Run. Now these images are getting uploaded. As you see on the screen, the images are uploaded successfully, and a new job has been triggered by the pipeline in the backend for you, right? So this is a job ID. You also get the job ID here. So what I'm going to do, excuse me, is copy this job ID, go back to my Google Cloud console. So over here, I think what I wanted to show you first was the Cloud Run runtime environment. So I have a few services deployed here. So the one that's handling the upload here is the upload handler here. And essentially, this is a web app running on top of a container hosted in a serverless way. So all you have to do is just plug in your GitHub code, and then it gets deployed automatically and can handle scale. Now, this also has the ability to give you monitoring metrics like the number of requests, latencies, and things like that. Now, on the other side, this is the Firestore collection, right? So once, say, Cloud Run handles the uploads, it also updates the Firestore database, as I mentioned. And here I have 3 collections, basically key value stores, which sort of keeps a tab of the status of the job, right? So here we, track both the upload status as well as the training and inference status. So if I go here under job details, you will see specific jobs that were initiated at the time of upload, right? And it will also show you what kind of Vertex jobs were initiated pertaining to individual designer uploads. So essentially, these collections can capture both your file uploads as well as your Vertex AI training and inference jobs. I'm just checking if the job that we just launched it's been updated or not. Just give me a second. Okay, this is the job ID. I think it's paginated here. Right, it should be here somewhere, right? So, once this gets updated here, if you remember the diagram, it will automatically trigger a Vertex AI pipeline. If you see the job that we just initiated, right, the pictures that we just uploaded have already been downloaded by the Vertex AI pipeline, configuration, and a new training job has been initiated. It's been about 2 minutes 48 seconds, right? So what this is basically doing, if I click on it, right, it gives you a nice tree visual representation of the different steps that Vertex AI pipeline is going through to train, fine tune and deploy your models, right, for your end app. So here I've just got 2 steps, but you can get innovative here, right? For example, if you need a pre-processing step, you can have that added as well. For example, to resize your images, or say if you want to do things like face detection, you can have an additional step before training, saying, hey, before initiating training, make sure that my images are resized in an appropriate manner and also label them accordingly. So you can do all kinds of stuff. So here, the training has been kickstarted. On the right, you can see the parameters that are being used. They're using a Tesla T4. You have the job ID, the job name, the machine type where this is sort of currently running, the number of GPUs, how many nodes are currently being used, so on and so forth, right? And once this is done, the output will be fed to the second model, second step, which essentially will then deploy and expose your model for inference, right? So I think the training takes a little bit of time. It's about 10-15 minutes since it's T4. A100s are usually much quicker. But if you want a quick view as to how a completed job looks, you can take a look at this, right? So here you have both the training and the inference completed. And once it's completed, essentially, you can go to online predictions on Vertex AI, and you will see the model deployed here, right? So this is like the end state. It's currently showing as active. You will have the deployment ID as well. So if you click on it, it will show you a nice view into how many predictions this endpoint is currently handling in terms of inference, the error percentage, request per second, and all kinds of things. If you want to dive deeper and do debugging, real-time logs for inference is also available, right? Now, the best part here is you can also test your models directly from here. Now, since this is image to image, because the gamer is going to upload an image, a guiding image based on which a new weapon will be generated. We may not be able to do it here, but if it's, say, text to image or any other model that you're using, you can essentially sort of, it's like Postman. You can pass your JSON requests and test your model, and you'll find a response here, and you can see if it works or not. If you want to integrate with your code, then you can also do sample requests here, and you'll find the details and how exactly you need to integrate this with your app, so on and so forth. Yeah, so I think that's about the walkthrough of the deployment. So I think I'll hand this back to Nitin here at this point, just to give you a quick snapshot of how we, what sort of results we got after we launched this in production.
Hey, Sai, also, I think just time, we have a couple of questions as well. So Nitin, probably we can take a couple of moments to wrap up and then go into the questions.
Sure, absolutely. Right, so let me share this.
Okay. Okay. So I guess just a quick wrap up on after the collaboration with GCP, how's our results and what are we looking at for the next steps. So I think our training productivity definitely increased by about 50%. So with the accelerated training, we actually managed to reduce the time to insight. So if let's say we realize that, okay, these model weights don't work as well, we will just pivot it out. We will switch out the training iterations, we change the parameters and everything. So it helps us to save a lot of time and we want to reiterate the training. So our inference productivity also increased a lot because we want to, as Sai mentioned, time is important to us because we want to present these results to our users. So yeah, so that was something that we are really happy about. And of course, next steps, we are looking at TPUs. So TPUs are faster than the GPUs, which is something that we're also looking into in future. And of course, if we need to speed up even more, definitely we'll look more into TPUs. And of course, we're looking into new models like SDXL and also Google's Imagen. So we're actually actively testing it out to see, how can we improve the model's quality. And of course, Google Kubernetes Engine, which is what I mentioned before, GKE, and of course, fleet management to help, spin up nodes quicker, how we want to manage different studios and everything. Yeah, so I think that's a very quick wrap up and summary. Yeah, so
I know we have a couple of questions. So we've actually managed to maybe do a quick deployment to show you something in real time. And then I think that could perhaps give a bit more context to, I think there's a few questions and someone raised their hand as well. So maybe Sai, I'm just going to take over the screen for a while.
Yeah.
So I think a question about like, how do we take like color inputs and everything? So, so this is what you see. We put in maybe a few simple templates. Let's say I choose this one. And I'm going to go a bit crazy here. So, let's say I do something like that. I want it to look like maybe a bumblebee or something, right? So I give it stripes. And kind of like in a lot of our internal testing, that's where we really saw a lot of creativity and some operational hiccups as well. For example, we realized that users, some of them didn't put in a field. They just added in like an outline, right? So how do we solve for that? So let's say I give it like some flaming barrel. I'll give it like some color in the body. So I'm really going on the fly here. So sometimes we are also surprised at the outputs that we get ourselves. Okay, so maybe something like that. And then I click generate. So just some of like people's past works. And yeah, see the first output came out, second and third. I think, Nathan can go straight into some of the questions later about how do we take color inputs. But I think what is interesting is also taking into account how we know, how much to exceed from the templated outline, how much to keep it within, when do we need to put in a field, when do we not, how does it recognize the different tasks we can as well. So maybe we can take the first question. I saw something.
Adrian,
yes,
his hand.
Go for it.
So we have a question on the chat from Brian. So the question is, Elston, thank you for the amazing presentation. In the weapon creation flow that you shared, how did you formulate the user's coloring input to the model for image/weapon generation, since it's not the usual text image inputs?
Okay, so I think maybe I'll take that question. So I think for the first step that we looked at was the training part of it. So we actually paired it with captions, so image caption pairs. So in the captions, we actually try to capture as many colors as possible. Then, of course, with the training images, these are actually game designer approved images, or rather the game designers themselves, the artists drew it themselves. So those are like that's the first step we get like proper images. And second, we caption it exactly specifically like the colors to capture the whole input or the whole accurate as possible description of the image. And then we also in the inference part of it, we try to keep it as much as to Battle Showdown style. So that's why you can see it's always this animated or like a little bit of a cartoony style. Yeah. So and I guess that's how we keep the coloring input as close as possible. And I think challenges that we faced when training and optimizing the models, I think one of the most common challenges, as with every other fine-tuning process, would actually be selecting the right compute power. So how much GPU, how much compute power we need, and, the hyperparameters. So hyperparameters is something that we experimented with quite a bit. So we actually did model checkpointing, to go through many training steps to pick out which one is the best. And we align back with our metric to see how we can go about it when training and optimizing. So how we can optimize it, we actually we did load balancing tests to optimize the model. So we actually did a whole series of load balancing tests to see how much we can support at a concurrent rate. So how many requests can we support in a second, or the concurrency, the simultaneous users hitting it at the same time and everything. Yeah.
Perfect. Brian, if you have any follow-up, feel free to unmute, or you can reach out to us later as well.
Yeah, just on the point of challenges with inference, mainly, I think one of the things that we worked on was how to improve the speed at which the pods were scaling, especially when we were doing benchmarks. Because one of the things with Vertex AI is you can define the minimum number of pods and maximum number of nodes. Sorry, not pods, nodes. And every time when there is a sudden burst in traffic that we tested, it took some time for the new node to kind of come up, download the artifacts and be ready for inference. So we had to do a little bit of an adjustment in terms of, what's the threshold required for CPU utilization or GPU utilization before a new, node was spun up. We also wanted to make sure that there are certain nodes spun up in some sort of a pre-warming sort of way, so that we are always sort of ready for handling sudden bursts in traffic. So, and that's one of the reasons why we are also exploring GKE now, because at GKE you have better flexibility for scaling.
We have one more question from Fabian. It's about, are you using Vertex online prediction to make image-to-image inference requests? If yes, how do you manage to scale your backend, given online prediction requires blocking synchronous HTTP requests, one hanging thread per request, or a different architecture?
No, that's
Okay.
right. That's actually bang on, because as it's rightly pointed out, there is a queuing system for Vertex AI endpoints, where at any given point in time, only one image generation job is handled, right? Or request is sort of serviced. The way we are currently handling it is we have enough nodes, spun up in the backend, which can handle the image generation process overall. But for future scale, we want to move this architecture to GKE, move it to A100s, especially for inference, and do things like GPU time sharing, and minimize the overall time it takes for the image generation. I hope that answers the question. Is it Fabian? Yeah.
Yeah. Yes, I think he's okay. Awesome. Yeah. Perfecto. I think we are on time as well. If you have any more questions, feel free to reach out to us to the email ID build in the cloud, which is BUIDL in the cloud at google.com. Happy to have more follow-ups and go deeper with, either with the Ethlas team or with us as well.
Did Adrian raise his hand? I think he had a
I think it
question.
was by mistake.
Oh, okay.
Yeah. Alrighty. Perfect.
Thanks a lot, folks.
Awesome. Thanks, everyone. Really appreciate you all joining. Thank you.
Thank you. Bye.
Thanks, everyone.